CL. Okay, chapter 10. So we're only doing a couple lessons in chapter 10. We're not doing all of them. Maybe? Thank you. There we go. There we go. Okay, so 10.2, we are simplifying radical expressions. When I refer to a radical, what do I mean when I say radical? We'll talk about reciprocal in a second. Maybe not reciprocal. Do what?
I said it was super cool, like that.
Radical. Yes, okay, got it. That's a good one. That's a joke I would make, so not sure what to do with that. When I refer to radical, all I mean is the square root symbol. Yes?
I see Peyton and Dylan and Megan, please.
Okay, so as I look at radical, all I mean is the square root symbol, which you're kind of familiar with. Okay, now to simplify square roots, we are going to use the perfect squares that we talked about in the warm-ups. We are going to look for perfect squares inside the square root. So we are looking to simplify radicals or simplify square roots. We are looking for perfect squares underneath the square root. And the reason we want to do that is because, like we talked about on the warm-ups, I can take the square root of perfect squares. I know the square root of 9 is 3. I know the square root of 25 is 5. So we want to look for perfect squares underneath the square roots so I can actually take the square root of it and get a number. Okay, perfect squares. You will need to have these memorized like we talked about on the warm-ups. So 1, 4, 9, just listing them again. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Okay, those are the basic one. So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. So we're looking for those perfect squares in there so that we can actually take the square root of those. Sean, keep your head up, please. After 100, 121, 144, 169, 186. What was 86? 96? Is that 14? Yeah. 225, 256, and what is it? 289. Okay, so those are all the perfect squares that you will have to have memorized by Thursday. So these are the numbers that we are trying to look for underneath the square root, because I can take the square root of these because they are perfect squares. Okay? So as I look at as I look at A, the first example A, I want to find the biggest one of these numbers that goes into 80. So as I look at it, take your calculator. If you cannot do in your head, or if it's a big number, look at your calculator. So everyone have one. And we are going to start with the perfect square. Some of you guys might be able to do this in your head, and that's okay. But let me just show you how you can do it if you can't. You are going to start with 80. And you are going to look for the biggest perfect square that is right underneath it. We cannot go over. So what is the perfect square that's right underneath 80? 64. So we're going to take 80 divided by 64. Does 64 go into 80 evenly? No. So we're going to do the next one. 80 divided by, what's the next biggest one? Some of you guys are not paying attention. No. The next one, it has to be under 80. So I start with the one that's right underneath it, which is 64. And then I do 80 divided by 49, which does not come out even. So I'm looking for the biggest perfect square that multiplies into 80. Next one will be 80 divided by
9 or 16 or something like that.
well, let's try 20, what is it? 36 is the next biggest one. That doesn't go in even. 80 divided by 25 doesn't go in even. The next one would be 80 divided by 16, and that goes in even. It goes in 5 times. So you want the biggest perfect square that goes into 80. So unless you can think about it in your head, if you can, you don't have to do that step-by-step process. If you can't, start with the biggest perfect square that's right underneath it, and then just work your way down and start dividing it. So I'm going to rewrite 80 as the square root of 16 times what? 5. So all I'm doing is I'm writing 80 as a perfect square times something else. And you want to pick the biggest perfect square. Now what is the point of getting a perfect square in there? What is the square root of 16? 4. So that goes out front. You can actually simplify the square root of 16. That's why I want a perfect square, because I can actually take the square root of 16 and get a whole number. Square root of 16 is 4, so I bring it out front. I've already taken the square root of 16, so 16 isn't under the radical anymore. Can I take the square root of 5? No, so that stays in the radical. So that is the simplified square root of 80. Simplified is 4 square root of 16. So we want to look for a perfect square, put it in there, write it as multiplication, and then actually take the square root. Square root of 16 is 4. That's a whole number. I bring it out front. Cannot take the square root of 5, so leave it square root of 5. I do not want decimals. So do not just plug in your calculator square root of 80. I will not give you any points for that. I want you to simplify like this. Okay, next one. Square root of 54. Okay, if you can think about it in your head, you can do it. I see it's an even number, so I might kind of give you some hint. If not, just start with the perfect square that's right underneath it. So what is the closest perfect square to 54 without going over?
49.
So 54 divided by 49, you already kind of know just by looking at it. It's not going to come in even. So let's do the next one. 54 divided by 36. Nope, 1.5. 54 divided by 25, you can just look at that. 25 is probably not going to go, won't go into 54, but we'll just do it. Next one, 54 divided by 16. Nope. 54 divided by 9. Yep. So you want to find the biggest perfect square that multiplies into it. So I'm going to rewrite the square root of 54 as a square root of what? 9 times 6. It doesn't really matter which one you put first. I tend to put the perfect square first just because I'm going to be actually taking the square root of it. Okay, what is the square root of 9? 3. So where do I put it? Okay, and then I have the square root of 6. It's not a perfect square, so it's not going to come out as a whole number. So I just leave it as the square root of 6. So 3 square root of 6. Okay, any questions on that? Okay, let's look at C real quick. Square root of 180. So let's find the biggest perfect square that goes into 180. Let's just kind of think about it. So you could go through and you could take 180 divided by 169, 180 divided by 144, 180 divided by 121. Or you can just kind of look at it. What's going to be the biggest perfect square that goes into 180? 36. 180 is 36 times what? 5. So if you do 180 divided by 36, it is 36 times 5. So rewrite it as 36 times 5. I'm not doing anything like super hard. I'm just rewriting it as a perfect square times something. What is the square root of 36? 6. So I bring it out front. 6 square root of 5. And that is my answer. Did you guys do this in middle school? No. Okay. Any questions? You did perfect squares in middle school, I think. Maybe not this. Maybe not. Okay? So any questions on that? Okay. Example 2, we are looking at multiplying square roots. Do not make it harder than it needs to be. You are just going to multiply underneath the square root you're just going to multiply underneath the square root, and you are going to simplify out the perfect square, just like we did on the first example. So if I am multiplying square roots, all you do is multiply underneath them. That is it. And then you simplify like we just got done doing. So as I look at A, I have the square root of 2 times the square root of 14. If I am multiplying, you just multiply underneath the square root. What is 2 times 14?
28.
So I want to have the square root of 28. So you just rewrite it as the square root of 28. So I go through and I look for a perfect square that goes into 28. So as I look at them, what is the biggest perfect square that goes into the square root of, or goes into 28? You don't have to look at anything over 28, so 25 down is all you really need to look at. 4 times what? So I'm going to rewrite it as 4 times 7. Dylan, keep your head up, please. What's the square root of 4? 2. Where do I put it? In the front. So 2 square root of 7. And that's your answer. Part of it will be it, yeah. So it might be, the nice thing about this is it doesn't take like 5 minutes to do a problem like the quadratic formula or factoring or all that stuff. Okay, any questions so far? Okay, now real quick, let me just change it. Let's say I had 2 square root of 5. Let me just change B real quick to make it a little harder. And 3 square root of 10. Okay, if I would have a number out front, it's not really any more complicated. So let's say I changed example B to 2 square root of 5 and 3 square root of 10. If I would have a number out front, all you do is you multiply the numbers out front and you multiply the numbers underneath. You cannot multiply numbers that are out front in the radical and inside together. You have to multiply them separate. So all you do is you multiply the numbers out front. What's 2 times 3? 6. And then you multiply the numbers inside the square root, which is going to be square root of what? 50. That's all you do. If you have numbers out front, you just multiply the numbers out front, and you multiply the numbers under the square root of 50. This is not simplified because there is a perfect square that goes into 50. So as I look at it, what is the biggest perfect square that goes into 50? Times what? So we are going to rewrite 50 as 25 times 2. So after we multiplied it, all we do is just like we did on example 1. What is the biggest perfect square that goes into 50? Okay, now that I have it, let's simplify. What is the square root of 50? Or sorry, what is the square root of 25? 5. I bring it out front. I already have a 6 there, so I just multiply the 5 and the 6. So when you bring that square root of 25 or the 5 out front, you multiply by the 6 that's already out there. And then I just have a square root of 2 underneath there. So it's just 30 square root of 2. Okay. Questions on that? Maya, stay with me, please. Make sure you're getting this down. Okay, let's look at C real quick. I have square root of 6 times square root of 8. Let's just throw, 5 in front. 5 square root of 6 times square root of 8. Okay, let me just rewrite it a little bit so it's a little trickier. So the square root of 6 has a number out front. So if I'm multiplying them, you multiply the number out front. So what's the only number I have out front? 5. So it's just a 5. Square root of 6 times 8? 48. So you can only multiply the numbers that are on the outside, which would be the 5 and the 1, technically in front of the square root of 8, and then multiply the numbers on the inside. Now this is not simplified because 48 has a perfect square that can go into it. So what is the biggest perfect square that goes into 48? 16 times what? 3. So make sure you get the biggest perfect square. 4 is a perfect square, but it is not the biggest. So you would have to do it again. What is the square root of 16? 4. So if I bring the 4 out front, what do I do with the 5 that's already out there? Multiply. So it is 20 square root of 3. How do we feel about this stuff so far?
So we did, I'll give you double notes.
No, sorry. You have a few more to do. Any questions so far? 0. Okay. Now, example 3, we are going to do the same thing, but now we are simplifying square roots with variable. We're just changing one little thing. Okay, simplify the coefficient. Like normal, and coefficient is the whole number. So when I say the coefficient, it's the big whole number out front. So it's not the exponents, it's the number out front. So simplify the coefficient like normal, like we just got done doing. Okay, the exponents are where it gets tricky, so make sure you write it down. I like writing it down so you can read it, and then we'll do a couple examples. Take the exponent and divide by 2. So we're going to take every exponent and divide by 2. How many whole times 2? So how many whole times 2 goes into the exponent becomes the exponent out front? So how many whole times 2 goes into the exponent becomes the exponent out front? The remainder becomes the exponent on the or inside the radical or the square root. Okay, kind of complicated, but I wanted to write it out so if you're a kind of a visual person and reading it helps it make sense, you have this. So you're going to take the exponent, divide by 2. However many whole times it goes in becomes the exponent out front. However many, whatever your remainder is the exponent inside. Okay? I'm not going to ask for questions yet because you're probably confused, but let's look at a couple examples. Okay, example A. Your coefficient you treat like normal. So as I look at A, what would be my coefficient? 90. So 90 you treat like normal, just like we got done doing. So what is the biggest perfect square that goes into 90? Do what? I want it to multiply into 90. So what's the biggest perfect square that multiplies into 90? 9 times 10. So I'm going to rewrite it as 9 times 10. And then I'm going to just write my exponents here. Okay, so your coefficient you treat like we just got done doing. So do nothing different with that. Your exponents is where it's going to get tricky. Now let's go through and simplify. What is the square root of 9? So I bring it out front. Now leave some space because we're going to be putting some other things out front. And then just go from left to right. Can I take the square root of 10? No, so that stays in the square root. And now let's look at each of my exponents. So pay attention here because the exponent is where it gets tricky. Take each exponent and divide by 2. So we're going to look at my x. The exponent is 3. 3 divided by 2. How many whole times does 2 go into 3? 1. That becomes your exponent out front. However many whole times, when I take 3 divided by 2, however many whole times 2 goes into 3 is the exponent out front. So 2 goes into 3 one whole time. And what will be my remainder? If I take 3 divided by 2, what will be my remainder? If I take 3 divided by 2, what's going to be my remainder? How many are going to be left? 1. So x to the first stays in there. So how many whole times 2 goes into the exponent goes out front. So x to the first. Whatever my remainder is going to be the exponent on the inside.
Do you have to put the first?
Yeah. No, I just put it so you can see it. You don't need the first, no. Now let's look at my y. We're going to take the exponent, divide by 2. 4 divided by 2. How many whole times does 2 go into 4? 2. So that is the exponent out front. And what is my remainder? If I take 4 divided by 2, what is my remainder? If I take 4 divided by 2, do I have any remainder?
Is there anything left?
Is there anything left when I take 4 divided by 2?
No.
No. So since I don't have a remainder, there is no exponent on the y inside here because there's 0. The remainder is 0. Now let's look at my 5, my z to the 5th. 5 divided by 2, so how many whole times does 2 go into 5? 2. So that's my exponent out front, z squared. What is my remainder? Z to the first. So you don't really need the first power. So 3x y squared, z squared, square root of 10xz. Now does anyone see you can kind of see a pattern. So if I'm dealing with the square, if I have an even exponent or an odd exponent, you can kind of see a pattern. We'll look at another example and see if you see the pattern. Are there any big questions on this one? Okay, let's look at B real quick. Exponents definitely make it trickier. Okay, square root. Let's look at my coefficient first, 32. What is the biggest perfect square that multiplies into 32? 16 times what? 2. So I'm going to rewrite it as 16 times 2. And I'm just going to rewrite my exponents. We'll deal with those in a second. Okay, what is the square root of 16? 4. So I bring it out front. Leave some space for your variables. Square root of, let's start from left to right. I took the square root of 16, which is 4. Can I take the square root of 2? Can I take the square root of 2? No. So it's just a 2. And now let's look at my exponents. If I look at my r, you're going to take your exponent and divide by 2. So 2 divided by 2, how many whole times does 2 go into 2? 1. So that becomes my exponent out front, r to the first. I'm not going to write it. Is there any remainder when I take 2 divided by 2? No. Now let's look at my k. K to the 4th. 4 divided by 2, how many whole times does 2 go into 4? 2. So that is the remainder out front. And do I have, so that's the exponent out front. Do I have any remainder when I have 4 divided by 2? No. So there's no exponent left in there. And let's look at my t to the 5th. 5 divided by 2, how many whole times does 2 go into 5? Twice. So that's the exponent out front. And what is the remainder when I do 5 divided by 2? 1. So that is the exponent inside. Now, anyone see a pattern? When I have an even exponent, what will my remainder always be? So like r squared and k to the 4th, those were even exponents. When I have an even exponent, what will my remainder be if I'm dividing by 2? Nothing. So anytime I have an even exponent, will there be anything left inside the square root? No, because there will not be any remainder. When I have an odd exponent, like t to the 5th, what will always be my remainder in here if I have an odd exponent? 1. So you can kind of see a pattern if you kind of catch on to it. Okay, so I got one more. That's my final answer. Okay, for this one. Okay, let's look at C. So square root of 56, x, y to the 10th, z to the 5th. So as I look at my coefficient, 56, I want the biggest perfect square that goes into 56. So as I look through my perfect squares, what is the biggest perfect square that goes into 56? Is it 4?
Yeah.
Yeah, 4. So square root of, so 56 is 4 times what? 14. So rewrite 56 as 4 times 14, just like we did on example 1. Okay, let's go ahead and go through, just rewrite your variables. We'll deal with those in a second. Okay, we're going to start with the 4. We're going to go from left to right, and we're going to simplify this. What is the square root of 4? 2. So I bring that out front. I'm going to leave some space. Can I take the square root of 14? Will square root of 14 come out even? No, so I leave it underneath the radical. And then I start looking at my exponents. So I have x to the first. How many whole times, if I take 1 divided by 2, Sean, keep your head up please. How many whole times will 2 go into 1? 0. So if 2 isn't going to go into 1 any whole times, will I have an exponent out front? No. So this is just going to stay x to the first inside here. Okay? So if I have an exponent of a 1 inside the square root, 2 will not go into 1 any whole time. So there's no exponent out front. It just stays x to the first inside the radical. Now let's look at the y. So y to the 10. 10 divided by 2? 5. 2 goes into 10 5 whole times. So that becomes the exponent out front. Y to the 5th. 2 will go into 10 5 whole times. That is my exponent out front. And what's going to be my exponent on the inside? What's my remainder? Anytime I have an even number, will there ever be a remainder when I divide by 2? No. So is there any exponent left on the inside? No. Let's look at z to the 5th. 5 divided by 2. How many whole times does 2 go into 5? Twice. So that's z to the 2nd. And do I have any remainder? If my exponent is odd, what's always going to be my remainder? 1. So that's z to the 1st on the inside. And that is your final answer. So exponents are a lot trickier, but they're doable. Any questions on that? Okay, take a couple minute stretch break. The notes are a little longer today because we didn't have homework to go over. So a couple minute stretch break. We only have 4 more examples to do. So take a couple minute stretch break. We'll come back to finish 4 and 5.
Wait, what did you say? Me or
I think you. I just got really high in the middle. I was like, what did you do? Did you get him some number?
No, because I was like,
They come back and they have touch.
yeah.
I felt so good, like holding my hair and like.
What are you silly? I'm not good. You're saying anything just to make him stink. No, it's not. It's just like sure. And then he's like sent me a game and I was like, he's like, I'm gonna play, and I was like,
Don't say anything too bad because we're still recording. Just FYI.
he's like, don't kill me.
It's not
And
my
he was
hip
like,
hop.
and I was like, he's like, it's your fault. No one answered him back.
Says it's false.
Huh?
And then he Snapchatted me, and he's like, still like my haircut, and was like,
Bro, I love his haircut.
it looks so much better.
So we gotta do like 2 times more with the notes and that.
Huh?
So we gotta do 2 times more.
No, that's not halfway. That's more than halfway. Oh, it's not counting. It's broken. Sorry.
There's a gap right here. I felt that.
When I say him, like,
But like when he brushes his teeth, it's better. But when he does it, like after school,
Okay.
like during school.
Let's finish these real quick.
That was definitely a
Edward
trigger. My mom had long sleeve.
Okay, so now we are looking at rationalizing a denominator, and this is something you'll see in Algebra 2. Not sure in geometry how much, but you will see it again. The big thing with square roots, there can never be a radical, or there can never be a radical in the denominator.
Wait, I forgot to ask you, what did you guys do last Thursday?
I don't remember.
Same.
Took notes. The notes are online.
What day?
Thursday. We took notes over graphing quadratic inequalities. The notes are online. So, were you here Friday?
We didn't go to school Friday.
That's true. Oh, Thursday was Alex. So, it was Alex. Okay, so what you're looking at is there can never be a radical in the denominator. So as I look at it, we cannot have a square root in the denominator. So this is how we take care of that. We are going to take the square root of the top and bottom separately. So that's the first thing you do is you take the square root of the top and the bottom separately. And then you multiply the top and bottom of the fraction by the denominator. Okay? So as I look at it, this will make more sense as we actually look at an example. We want to write the square root of top and bottom separately and then take the top and bottom and multiply by the denominator. Okay? Let's look at a couple of these. We're not going to do all of them. Let's look at A real quick. So if I look at A, first of all, we can split up the square root and the top and bottom separately. So square root of 35 and over square root of 15. You're allowed to do that. So when you are dividing underneath the square root, you can just take the square root of the top over the square root of the bottom. Now, you cannot have a square root in the denominator. So right automatically off the top, right off the bat, I have a square root of 15 in the denominator, so we are going to get rid of that. So step 3 says we take the top and bottom and multiply by the denominator. So you are going to take the top and bottom, square root of 35 and the square root of 15, and multiply by the denominator. Do not make this harder than it is. We talked about in example 2 how to multiply radicals. All you do is multiply underneath it. So as I look at it, that equals, what is the square root of 35 times the square root of 15? Use your calculator. Square root of 525. Now, as I look at it, if I have the square root of 15 times the square root of 15, what is the square root of 15 times the square root of 15? Square root of 225. I'll tell you a shortcut for that in a second. Now as I look at the square root of 525, what is the biggest perfect square that goes into the square root of 525? So start taking 525 and start dividing it by perfect squares. Now if it ends in a 5, I would try things that end in a 5. 25 times what? So I'm going to rewrite it as 25 times 21. So we're simplifying it just like we did. And what's the square root of 225? 15. So here's the shortcut. If you are multiplying, if you look at the square root of 15 times the square root of 15, if you are multiplying with the same number under the radical, then your answer is just that number. So square root of 15 times the square root of 15 is just 15. And let's simplify the top. What's the square? We're not going to do B, so you can run into that space. What's the square root of 25? So bring it out front. So 5 square root of 21, like we've done before, over 15. And how can I reduce it? Think of 5. Think about the numbers outside as a fraction. 5 over 15. How can I reduce 5 over 15? Okay, so that's going to be what? Yep. So 1 square root of 21 over 3. So 5/15, think about it as a fraction, just reduce it as 1/3. And you don't really need the 1 in front. So square root of 21 over 3. You cannot divide it because you can't take 21 divided by 3 because the 3 is not under the square root. You can't multiply or divide if there's One inside and one's outside. Okay, any questions on that? That's your answer. Okay, let's look at C real quick. If I look at C, okay, first of all, write it separately. Square root of the top and bottom. So square root of 3n over square root of 8. I cannot have a square root in the denominator, so I'm going to have to multiply the top and the bottom by what? Square root of 8. So you multiply top and bottom by the denominator, so square root of 8. So top times square root of 8, bottom by square root of 8. Now whenever you multiply, you just multiply underneath the radical. So what is the square root of 3n times the square root of 8? What is it? 24n. All over, what is the square root of 8 times the square root of 8? Square root of 64, which is just... So like I said, when you have the same number under the radical that you are multiplying, it's just that number. So square root of 64 is just 8. Okay, let's simplify the square root of 24 part. We'll do it down here. Square root of 24, what is the biggest perfect square that goes into 24? 4 times what? 6 all over 8. Just like we did earlier on the front page. What's the square root of 4? 2. So bring that out front. 2 square root of 6n over 8. And look for your fraction. 2 over 8. How can I reduce the fraction 2 over 8? 1/4. So square root of 6n over 4. Because you don't need the 1 on top. Okay, any questions? Okay, one more example, we'll be done for today. I know, long notes. We're only going to take those twice this week.
How'd you get rid of that 2? How many more tests are we going to have?
One more. What'd you say? Sorry.
How'd you get rid of that 2?
Because 2 over 8 reduces to 1/4, and I don't need the 1 on top. Any other questions? What did you say, Destiny? Were you complaining? Okay. I don't remember. I didn't listen to what you were saying. Sorry. Okay, conjugate. So when I look at the conjugate just means the opposite. Okay, so we are still rationalizing a denominator. So we'll look at example B real quick. As I look at example B, I have a square root underneath in the denominator. I have the square root of 7. I cannot have the square root of 7 in the denominator, so I need to get rid of that. So to get rid of that, we are going to have to multiply the top and bottom by the conjugate. So what that means, it is the opposite. So instead of 3 minus the square root of 7, we are going to multiply the top and bottom by 3 plus the square root of 7. Now, if you want to rewrite it like this, it might be easier to kind of think about what we're doing. 7 times 3 plus square root of 7 over 3 minus square root of 7 times 3 plus square root of 7. So this is just rewriting it with parentheses. 7 times 3 plus square root of 7, 3 minus square root of 7 times 3 plus square root of 7. Now when I put parentheses, it is easier to see how we're going to do this. So on top, we are going to do what? Distribute. What's 7 times 3? And then what's 7 times square root of 7? Because they're not both under, you can only multiply them if they're under both the square root. So that's just going to be 7 square root of 7. That 7 is not under the radical, so you cannot actually multiply them together. So you just put 7 square root of 7. On the bottom, what will I need to do on the bottom to multiply it out? It is a binomial times a binomial. So what special word do I have, term do I have for multiplying a binomial times a binomial? Should know. We talked about it a couple months ago. I have a binomial times a binomial. What do I have to do? Hunter, stay with me. Binomial times binomial. I'm not going to answer you guys because you guys are almost done with Algebra 1. You should know this. Binomial times a binomial. What special term do I have for multiplying that?
What's that called when you're distributing it?
I would start looking at your notes. It's not in chapter 9. It was in chapter 7 or whatever. If I have a binomial times a binomial, what special word do I have for distributing it?
I see about one person looking
Yes,
for their notes.
you guys aren't really trying, so you're just
Okay.
wasting homework time.
Check out your notes.
You guys are almost done with. Do what? No. You guys are just saying stuff. I get today we've taken a lot of notes, but we only take notes 2 or 3 times a week. You are fine. You are almost done with Algebra 1. You should know what when I multiply a binomial times a binomial, what that is called.
Difference.
Do what?
Difference.
So what special name do I have when I multiply a binomial times a binomial? You should know how to do it. Huh?
And where's a trinomial from?
You will get a trinomial in this case as an answer, but that's not what it's called. When I have a binomial times a binomial. We are multiplying a binomial times a binomial. You can use, I don't care if you use Google, I don't really care. Find it somewhere. It's a basic thing. You should know it from Algebra 1. When I multiply a binomial times a binomial, what's it called? That's fine, I don't care. Find it somehow. I've said it 3 times.
First terms, outside terms.
What's that called?
Outside terms, last terms, special case, multiply.
What's that called? You just said it. You multiply, just a second, you multiply first terms, outside terms, inside terms, last term. FOIL. So this is how you multiply a binomial times a binomial. You FOIL it. Okay? So we are multiplying my first 2 together. So as I look here, we are looking at my denominator. What is 3 times 3? 9. So that's multiplying my first 2 together. Now my outside 2. 3 times square root of 7. What is 3 square root of 7? What is 3 times the square root of 7? Nope. What is 3 square root of 7? We just talked about it up at the top. What is 3 times the square root of 7? Nope. Nope. We just talked about it on top. Some of you guys are not paying attention very well. When I did 7 times the square root of 7, I told you what it looked like. So what's going to be 3 times the square root of 7? No. 3 what? Yeah, so plus 3 square root of 7. I cannot multiply them together because the 3 is not under the radical. So you just put plus 3 square root of 7. When I multiply my inside 2, what is a negative square root of 7 times 3? Negative 3 square root of 7. And then multiply my last 2. What is a negative square root of 7 times a positive square root of 7? Yep, but I told you your shortcut. When I'm multiplying 2 numbers with the same number underneath, what's my answer? 7. So it's just minus 7. Now as I look at the bottom, my top I cannot simplify. So 21 plus 7 squared is 7. On the bottom, what do you notice can I cancel out? These are one term, so what two terms can I cancel out? Yeah. Positive 3 squared is 7, negative 3 squared is 7, so I'm just left with what? And what is 9 minus 7? And that is my answer. So when you multiply by the conjugate, it will always cancel out nicely, which is what we wanted to do. I want to get rid of the square root in the denominator, which I did. Okay, so homework is going to be page 631, 1 through 13, 29 through 35, and 49. Let me double check on that. Make sure that's where I want to give you. So 631, the odds, the nice thing about going back to the book, the odds are in the back, so you can check your answers.
You're saying just the odds of these? Or all of them?
All of them. So 1 through 13, 29 through 35, and 49. There are a couple story problems. You guys can do sort problems. They're very doable.